Assalamu alaikum wa rahmatullahi wa barakatuh. Today's video is on how to ace that last 6 marker question, that annoying question that many people think it's annoying, but I'll be honest, this is the easiest question on the paper, and it's the easiest question to actually score marks in, because it has so many elements that you have like the choice to write and you can still get marks. I mean, in some marking schemes, just writing variables alone could give you 3 marks out of 7 or 6 confirmed. So that's 50% of the marks you're getting just by writing variables. Then you have the methods, then you have the repeating it, then you have the table, the conclusion. I mean, it's so easy to get the marks in this question, and I would suggest do this question at the end, because the first question could be about maybe cooling rate and the second question could be about electricity, and if the last question usually is from those two things, cooling rate and electricity. So if you do get those if you do those questions first, like the cooling rate and electricity, in question 1, 2 or 3, then in question 4 it will be easy for you, because you would have built momentum to solve it. And yeah, this is a perfect guideline on how to ace those marks, and we'll be going through obviously an actual example. But yeah, so let's move. Okay, so basically this is like the formula of what you need. You need to memorize these 6 things. Okay, the variables. Okay, let me get my the variables, the method, the table, repeating, and average. Average also really important. Average. Then we have conclusion and additional apparatus. So we'll go through this one by one. Okay, so step 1, variables. Okay, so variables are of 3 types. Okay, in this type of question: independent variable, your dependent variable, and your control variable. Or you can write as constant, but it's better to write as control. Actually, don't write constant. Okay, yeah, control. So independent is what you change. Okay, example, changing the temperature of the wire. Dependent is what you measure. Example, measuring the resistance using an ohm meter, or measuring the current of any circuit component using a ammeter. And then control is what stays constant, meaning keeping the material and length of the wire same. So example, in independent, you could be changing maybe, example, in cooling rate, you could be changing the you could be changing the initial temperature. Okay, let's say you could be changing initial temperature for 2 beakers. Okay, if you have 2 beakers here, beaker 1 and this is beaker 2, just assume they have water in it. Okay, maybe this has 30 degrees and this has 40 degrees initial temp. Okay, this is initial temperature. Both of them have different, right? So you're changing. Example, in beaker 1 you took 30 and then in beaker 2 you took 40, so you're changing it. That's your independent variable. Okay, so example, if I were to say that in the question it said that investigate an experiment on how the resistance, or no, actually the cooling rate of a beaker depends on the initial temperature. Now if you look at that wording, it says depends on the initial temperature, meaning the cooling rate depends on the initial temperature. If the cooling rate depends on the initial temperature, that means you're changing the initial temperature for the cooling rate to change. What you're changing for something else to change is your independent. Then your dependent is what you measure. If I said that plan an investigation to measure or to find out how the cooling rate is affected by the initial temperature of the water, then what you're measuring that's affected is your cooling rate. So your cooling rate is your dependent variable in this example. And then constant, what has to be constant for it to be fair? You have to keep the whole experiment fair, right? Example, if this has more water and this has less water, then this is unfair, because the thing that you want only affecting is initial temperature, but in this case the volume will also be affecting, right? If you have more water here, less water here, then the cooling rate will be affected, but we don't want that. We want only the initial temperature to be independent variable, meaning the only thing that changes or influences others. So the volume of water has to be equal in both beakers. So a control variable could be volume of water. Then you can also have maybe room temperature, because room temperature, they have to be in the same room, so room temperature also has to be constant in this example. Or maybe the size of the beaker, both beakers have to be the same size. If one beaker is like this much and another we could do it here, like if one beaker is this much and then another is like this much, then there will be a difference in the cooling rate. Even if the level of water is same, the volume will be different, because this will have more volume and this will have less volume, so it'll be different. So this is an example. Obviously we'll go through an actual question so you guys will understand better, but just know independent is what influences others and dependent is what gets influenced, and control is what you keep everything same. Any possible thing that you think it can be same, just write it, but make sure it's correct. Okay, like in this case you can't write cooling rate as control, you can't write initial temperature as dependent and cooling rate as independent. It'll be completely wrong, and then your method will probably be wrong as well, and you'll probably get a 0, because your whole thing is dependent or not dependent. I'll not confuse guys. Your whole thing is basically what you're figuring out here. If you figure out your independent, dependent and control wrong, your whole experiment will probably be wrong. I mean, like 99.99% will be wrong. If you identify your independent, dependent correct, it will most likely be correct, regardless of the fact if you get control wrong or not. Okay, then step 2, write the method. Now look, when you're changing the independent variable, you have to change it systematically. When you're changing, what I mean by that is that if you're changing the initial temperature, you have to change it for one beaker and then the other beaker. Okay, it has to be in a sequence, systematic sequence. So you have to change it for, if you're taking beaker 3, beaker 4, it doesn't matter how many beakers you take. I mean, just take maybe like 10 or 15 or 5, I don't know, don't take 1 or 2, the beaker 5. Okay, then you're changing it systematically. So it goes the same for this. Measure the dependent variable accurately, like measuring in the sense that if you're saying a cooling rate, then you measure with a thermometer, like you tell the apparatus, and then the time with a stopwatch, and repeat for multiple values. Exactly my point over here, this. Okay, you have to repeat for multiple values, meaning beaker 1, beaker 2, beaker 3, beaker 4. You cannot just take one beaker, because then you're just measuring one beaker, you're not taking any other beakers into account. The point of any investigation is that you investigate many things to come to a conclusion, not just one thing. So, and then you have to also be a bit more specific. Like example, you say take readings. Take readings of what? If you're saying take readings of any from the voltmeter, then you have to say measure the voltage using a voltmeter. If you're saying measure the cooling rate, you're going to say measure the temperature using a thermometer, measure the time taken using a stopwatch, and use the cooling rate formula, which is temperature change over time. You have to use this. Okay, now for the table. Okay, for the table, many people, what they do is that, okay, I'll take another color. I'll take this color. Example, in the table, if I'm drawing a table like this, the table you can draw it any format, but example in a table, if they're asking you about cooling rate, okay, I'm gonna stick to cooling rate because that's what I started with. In cooling rate, you cannot put voltage, you cannot put ammeter, current, you cannot put resistance, you cannot put stuff that's literally does not make sense to cooling rate. In cooling rate, this is wrong. In cooling rate, you have to mention initial temperature IT, then your final temperature FT, and obviously degrees. It has to be in degrees. Okay, then the time taken, the time in seconds, then the cooling rate, CR, not Clash Royale by the way, CR, which will be degrees Celsius per second. So as I said, clear headings, the units should be shown, and consistent decimal places if you want to put values, but you should not put values if they have not asked you. I mean, they rarely ask, but if they do, then you have to put the values in decimal places, consistent decimal places, not 1 in 2 and then another in 4 or another in 6 or another in 1 SF, 2 SF, 3 SF. You can't. You have to put them in consistent, either 2 or 3 or 4 or so on. But you don't have to do this step. You can skip this because they don't ask you to put values in. So don't put it. Don't go against their instructions. But most people, they don't put the units, and they have a messy layout. Okay, like example, in initial temperature they don't put the degree Celsius, and in final temperature they also don't put the degree Celsius, which loses them marks. And this same decimal places throughout, this is because in some questions they may ask you in like question 3 specifically. This is for question 3 mostly. This is for question 4, but this is for 3. Like they may ask you put the voltage values after giving you a formula, and then you have to put it in the table. They may give you a table, and then you have to put your values. So it has to be either to 2 SF, 3 SF, but they have to be same decimal places or significant figures throughout. Okay, now repeating the readings. So this is also really important. After you have stated your method, always say we're going to repeat at least 5 times. To be on the safe side, you can write 3, but to be safe side, just write at least 5 times. At least 5 times. Okay, then you should say, then calculate average. We will repeat at least 5 times. We will calculate average, which will improve the reliability of my results, to maybe identify anomalous results, which are results that don't fit the trend. Okay, so this is really important. Mention how many times you will repeat. Mention that you will take the average, and then third, mention it improves your reliability. Now state the conclusion. Like if you just say it, the examiner does not know what you mean it. Okay, what do you mean by it? You have to mention it. It could be voltage, it could be a resistance, it could be your current, stuff like this. Okay, you have to mention. So example, resistance increases as temperature increases. State the trend clearly, name both variables, and show relationship. Okay, now again, you don't have to write this, but if you're writing something like cooling rate increases with respect to what? If you have greater temperature, then obviously cooling rate will increase, right? So you write that, but you don't write it will increase. The examiner does not know what you, even though he may have an idea, he does not really know what you're talking about. So you have to mention that. Then finally, additional apparatus. This is really important, and these 4 are the most common. They are the most common that they can ask: stopwatch, thermometer, voltmeter, ruler. If you see in a question and it says any add any additional apparatus, then you should know these 4. Most of these 4 come: stopwatch, thermometer, voltmeter, ruler. Okay, stopwatch is just to measure the time intervals accurately, or like 5 minutes, 10 minutes, 15 minutes, and then to monitor temperature changes, like of 30 degrees initial temperature, 40 degrees final temperature, something like that. Voltmeter is obviously to measure potential difference, and ruler, or it's better to write meter ruler. This is the most appropriate, meter ruler. Okay, I'll circle this, meter ruler. Meter ruler is really important. Okay, like example, if you want to measure the length of something, maybe the length of a wood, a piece of wood, then you use a meter ruler. Anything if it says measure the distance, something like distance, like maybe distance is the keyword, then you use a ruler. If they say voltage, then you use a voltmeter, or if they say EMF, or they say potential difference, then you use a voltmeter. If they say if they say time, then you use a stopwatch, and if they say temperature, then you use a thermometer. These are like the keywords. Then finally, draw the circuits correctly. Example, if they ask you to draw the ammeter, then ammeter will be in series, right? Oh, my bad. Yeah, okay. You can't draw an ammeter like this or like this. You can't draw something like this. This is not an you can't draw an ammeter like this. But in parallel you have to draw the voltage like this, right? And then variable resistor is also really important. I've told so many times, variable resistor is like this, okay? Lamp is like this, just a circle and then two crosses, okay? That's it. They may ask you to draw a cell or a switch, but that doesn't usually come. It's mostly ammeter, voltmeter, variable resistors, lamp, maybe just a normal fixed resistor. That's it. Maybe even a thermistor. Thermistor is like this, or maybe even a potential divider. So you just have to draw all of this. Just memorize the circuits. I have made a video on it, so you should check that out as well. So finally, this is the last question checklist: your variables, your methods, your table, repeating and then taking average, conclusion, apparatus, circuit symbols if they have asked you, and you're ready to ace paper 6. But not yet, because we're gonna do an example question now. Okay, so we're back, and so this is the question from I think May-June 2024, paper 6-3, 0625 code. Okay, so I'll do this question live, like over here. So a student investigates the relationship between the diameter of a wire and the electrical resistance of a wire. So now you will obviously know that it's between diameter and resistance, right? Something related to diameter and resistance. So now it says, plan an experiment which enables her to investigate how the diameter of a wire affects the resistance of a wire. Now, what did I say before? Which enables her, like this question, it's completely based on what I have told before, because it says additional apparatus, completing the circuit as well. So yeah, it covers everything basically. If you can do this question, you can do all the others as well, okay? Obviously, as I said, the type of question remains it changes, but the pattern always remains same in every paper. So plan an experiment which enables her to investigate how the diameter of a wire affects the resistance. Now, how the diameter of a wire, meaning diameter, influences, let's remove this, let's say influences, okay? Influences the resistance. So what thing is influencing the other? Diameter, meaning diameter is the independent variable, and resistance is obviously being influenced, so it's the dependent variable. So we have cleared the independent dependent variable easily, so we know how our method is going to be like. Then resistance is calculated from the equation R is equal to V over I. Perfect. Where V is the potential difference across the wire and I is the current in the wire. The apparatus available includes wires of different known diameters. Okay, so they have given this apparatus that of different diameters. In your plan, list any additional apparatus needed. Complete figure 4.1 to show a circuit suitable for measuring the resistance of a wire. Explain briefly how to do the experiment, including the measurements to take so that the resistance can be determined. Constant variables, draw a table, explain how to use to reach a conclusion. Okay, perfect. List any additional apparatus. Now, what do you need? Since you want to first since you want to actually measure resistance, right? Resistance is the dependent variable, so you have to measure this, right? You have to measure this. Now what do you need? If you want to measure resistance, you need voltage and you need current, right? They have only given you this. They have only given you the different diameters, right? They have only given you the different diameters. That means they have not given you the voltage and current. How do you do that? To measure voltage, you use a voltmeter, and to measure current you use a ammeter. So those are the two additional apparatus that you need for this point. So this is covered. Then complete figure 4.1 to show circuit suitable for measuring the resistance of a wire. So you have identified voltmeter and ammeter, and I hope you guys know why. Because look, we have to measure the voltage and the current. We don't know how we'll measure the voltage and current. How? By a voltmeter and ammeter. They have not given a voltmeter anywhere or ammeter in this whole thing, right? So we need that. Now they said to complete the circuit. Since you know it's a voltmeter and an ammeter, you can now complete it. You know that the ammeter will be connected in series, so you can either connect it over here or you can connect it over here, but you cannot connect it like 2 times, just once, either in this part or that part. Okay, then you just make a straight line here. If you have connected in that side where I've put it over here, then over here just a straight line. Okay, wait, just a straight line like this. Okay, and then voltmeter is always in parallel, so we'll draw it like this. Okay, so that's 2 marks confirmed out of 7. This is 2 out of 7 confirmed. Then how we'll do the experiment? So now let's go over here and I'll explain side by side. So we know that the independent variable is the diameter of the wire. It's the wire. Yeah, it's the diameter of the wire. I thought it was something else, maybe any other component. Anyways, dependent. So the that's the independent. Then the dependent variable is the resistance of the wire, as we have figured out over here, right? So that's done. Now I want you guys to think what could be the control variables. Okay, what could be something that you need to control over here? So you need to know that in anything that may ask you diameter of a wire, think about opposite. What affects the resistance of a wire? You may have learned from paper 4 that it could have been either diameter, length, maybe material of the wire, maybe cross-sectional area of the wire, stuff like those. So those will remain same. All of those things will remain same. So type or material of wire will remain same, length of wire will remain same, then cross-sectional area will remain same. So all of those things will remain same. Okay, then you have identified all of that. Now the method. Okay, so we know that the diameter and resistance are the independent and dependent variables. So what we will do is that we will take one diameter value, diameter. We will take one wire with known diameter. Let's say it's maybe 3 centimeter. I know that's really a lot, but it's fine. With no diameter, let's say 3 centimeter. We will push through the EMF through source and pass through the source and measure the potential difference across wire using voltmeter. Okay, so we will take one wire with the known diameter, let's say 3 centimeter. We'll push the EMF through the source and measure the potential difference across the wire using a voltmeter. This is not important, okay? And measure the potential difference across the wire using a voltmeter. We will measure the current using an ammeter. Okay, because you need to know the voltage and or the potential difference and the current, because you need to put this formula to get resistance. Okay, so then we will calculate wait, I'll put it here. Then we will calculate the resistance using the formula R is equal to V over I. Okay, then I'll do it here. Then we will take another value for the diameter and do this 3 more times. Okay, so we will basically doing it 3 more times. We will repeat this whole experiment at least 5 more times for accuracy, 5 more times, and take the average for accuracy and reliability. Okay, so now up to this point I hope you guys have understood. We will take one wire with known diameter, let's say 3 centimeter. We will push through the EMF. Let's remove this. Okay, we will measure the PD across the wire using voltmeter. We will measure the current using an ammeter, and then we will find the resistance using the formula R is equal to V over I. We need to measure the voltage or the PD and the current, because we need to put it into the formula to get resistance, because that's what we are measuring, that's what we are finding, right? Then we will that's our whole experiment method, that's it. Then we have to take for another value. As I said, if you're making one beaker, you need to take for more beakers. So same over here, if this one wire, right, this is one wire, then you need to take for another wire. Okay, it's the same thing here. Then we will take another value for the diameter and do this 3 more times with other wires. Okay, we will repeat this whole experiment, everything, at least 5 more times and take the average for accuracy and reliability. Up to this point we may have secured 6 marks already. Then comes the table. In the table we have to draw something like this. In the table we have to draw just 3 things: the voltage, just write it, voltage, wait, I'll write it in with the text box. Voltage, which will be in V, obviously you have to write the units. Current, which will be in A, and then the resistance, which will be in ohm, which I'll have to draw actually. And yeah, so that's it, that's a table done, because we just need voltage, we need just current, and we just need resistance. Yeah, we also need the diameter. We have to also write the diameter, right? Diameter of the wire, diameter, and that could be in centimeter, maybe millimeter as well. Millimeter is also fine. And yeah, so that's the table done. And then finally conclusion, you always write in conclusion this: you always write that we will plot a graph, but you have to also specify we will plot a graph of the independent variable, which is the diameter of the wire, against the dependent variable, which is the resistance of the wire. That's it. Let's just fix this. This is, yeah. So that's how you get all of those 7 marks. And yeah, I hope that was simple. You just have to understand the question really is like properly, and everything else will become simple. As I said, if you understand independent dependent, your whole method and your table will be correct as well. So yeah, that's it. Thank you guys, thank you so much, and ace that paper 6, so that the examiner is also very confident in giving you all those 6 or 7 out of 7 marks, and not marks like 2 out of 7. Don't just do this meter and voltmeter and just leave the paper, okay, please. Okay, yeah, thank you guys, thanks so much.